Yes, good morning, students. Myself Vishnu Prasad, lecture professor in mechanical department, BITM College. So I am going to take the subject applied thermodynamics for the fourth sem students. Okay. So already I have given the introduction to the applied thermodynamics, and I have explained about the syllabus, all the modules, what all the modules we have, and in the last class also I explained uh, what all the chapters we are going to cover. And one more important things I want to tell is regarding this corona pandemic. So all the students be stay at home. Okay, so you people don't move outside, you regularly attend the classes, and what all the assignments we are going to give you, you please write it down and submit it as per the schedule given. Okay, so coming to the applied thermodynamics, in the first module we have two chapters, that is air standard cycles and IC engines. So I am going to explain about the IC engines now. Okay, so in the first class, in the last previous two classes, I explained, given some introduction. I have recalled some basic thermodynamics, what all the things are required for applied thermodynamics. So once again I am going to repeat it. So the what you have studied in basic thermodynamics, that is chapter 2, that is work and heat, that is important for you people. So in the chapter 2 work and heat, what is the work done in various process, and based on that it is very much important for the applied thermodynamics. If you understood well, it's okay. Otherwise, once again go through the chapter fundamentals, some conversions, pressure conversions, weight, force and weight conversions, unit conversions. Those are important for applied thermodynamics. Okay, so coming to the IC engine chapter. So once again I am going to repeat, what do you mean by IC engine means? It is nothing but IC means internal combustion engines. So it means that the combustion takes place inside the cylinder. Okay, the combustion means air fuel mixture combustion takes place inside the cylinder, which produces a large amount of gases at higher pressure. Okay, and makes the piston to reciprocate. So this is nothing but internal combustion engine. So now coming to the classification of IC engines. So already I have explained this classification, and even Raju Jadar has also explained for A section, I think. So once again I am going to briefly explain about the classification of IC engines. So you can look here, the classification of IC engines. So based on the cycle of operation, so we have diesel cycle, petrol cycle and dual cycle. Okay, next coming to the based on the strokes, so we have a 2-stroke engine and 4-stroke engine. So what do you mean by 2-stroke engine and what do you mean by 4-stroke engine? If the thermal cycle is completed in the movement of the piston 2 strokes, that is, if you take a vertical cylinder, if the piston moves from top dead center to bottom dead center, that will be 1 stroke. And again, if the piston moves from bottom dead center to the top dead center, that is another stroke. So within these 2 stroke, if the thermal cycle is completed, then it is called a 2-stroke engine. So what is that thermal cycle? So thermal cycle in the sense is nothing but the process that takes place for the completion of one cycle, that is a suction, compression, expansion and exhaust. So if this complete, again the suction, compression, expansion and exhaust takes place, so this is called as the thermal cycle in the IC engine. So if this cycle is completed by the movement of the piston in only in 2 strokes, then it is called as the 2-stroke engine. If the same cycle is completed in 4 times movement of the piston in 4 strokes otherwise, so such engines are called as a 4-stroke engine. Okay, so this is the second classification based on the strokes. And next we have a third classification based on the cylinders. So we have single cylinder and multi-cylinder engines. If there is only one cylinder, then it is called as a single cylinder engine. If there are more than one cylinder, it is called as a multi-cylinder engine. Okay, next based on the cylinder arrangements. So we have horizontal cylinder arrangements, vertical cylinder arrangements, and radial engines. So if the cylinders are placed horizontal, then it is called as the horizontal cylinder arrangement. If the cylinders are placed vertical, then they are called the vertical cylinder arrangements. If the cylinders are placed radially with a crankshaft at the center and number of pistons are connected to the different cylinders radially, such engines are called radial engines. So other than this, we have V engine and also opposed engines. So if the cylinders are placed in the shape of V shape, then it is called as V engine. Okay, and if the cylinders are placed opposite to the crankshaft, then they are called as the opposed engines. So this is the fourth classification based on cylinder arrangement. Next we have based on the speed. So based on the speed, we have a low speed, medium speed, and high speed engines. Okay, so next we have a based on the cooling system. So we have water cooled and air cooled engines. Means the engine has to be cooled. Okay, because it gets heated up. Externally it will be cooled, not internally. Externally we will be having a water jackets where the water will be circulating external to the engine. Such engines are called as the water cooled engines. If suppose there are the fins provided on the engine surfaces, by the movement of the vehicle, the atmospheric air comes into contact with the engine fins and the engine gets cooled. So almost all two-wheelers we have the air cooled engines, but of course nowadays we have even water cooled engines. Some high capacity two-wheelers also we have, there the radiator will be provided to cool the engine. Okay, so that is the sixth classification based on the cooling system. Next we have based on the fuel supply. So we have carburetor, fuel injector. Okay, so if the fuel is mixed in the carburetor and it is supplied to the engine, then we have a carburetor type engine, and we have a fuel injector. In of course all diesel engines are fuel injections. Okay, so this is about the classification of IC engines. So next we have indicated power. So before going for the indicated power, I am going to explain what I mean by detonation and knocking effect. Okay, so prior to this we have one more pressure theta diagram. Already I have explained that yesterday. Okay, so that P theta diagram is different and this detonation and knocking is different. So P theta diagram is nothing but a pressure theta diagram. As the piston moves from bottom dead center to the top dead center, BDC indicates bottom dead center and TDC indicates top dead center. Okay, so as the piston moves from bottom dead center to TDC, the air gets compressed, so the pressure will be risen. At the same time, we will be having on the x-axis a crank angle theta. Okay, so coming to the here detonation and knocking. So the first figure what you are seeing is nothing but a normal combustion. So what I mean by normal combustion means, you can see here the fuel is moved from, flame will be after the ignition, the flame will be moved from the point A to curve B, and then finally to the this you can see here slowly the flame will be moving, slowly the combustion takes place. There it is called as the normal combustion. If you look into this P theta diagram here, BDC indicates bottom dead center, TDC indicates top dead center, and again here the piston BDC comes back to its original position. So from the piston moving from BDC to top dead TDC in the left side, I have provided one point there, that is called as the ignition. So almost nearer to the TDC at the end of the compression or nearer to the compression, the ignition takes place where the gases will be formed, and these gases will be expanded, making the piston to expand. So again from the top it is coming towards BDC on the right side. Okay, means the expansion stroke is taking place, and here on the x-axis the angle will be mentioned as I have explained you yesterday in the class regarding P theta diagram. So if this combustion takes place normally, then it is called as normal combustion. But there are some cases where the abnormal combustion takes place due to ignition lag or pre-ignition. Okay, so there are some factors, I'll explain that. So if we look here, earlier the curve BB to D, it has got, I have shown only a single hatched lines, but here due to auto ignition or ignition of charge, there will be a sudden increase in rise in pressure. This gives a abnormal combustion. So you can see these zigzag lines are shown in the P theta diagram. So this is called as the knocking waves. So what are the reasons for this knocking waves? Means if the compression ratio increases suddenly, or the auto ignition takes place due to the increase in compression ratio, okay, or if there is a pre-ignition also, there will be a causes of auto ignition. So this causes the detonation or knocking. Okay, so due to this rapid deterioration, the engine parts, the abnormal, due to the abnormal combustion, the metallic sound will be provided. So due to the pressure impact on the surfaces of the piston and cylinder, this is known as a detonation or the knocking effect. So what are the factors that affect the knocking is important. So what are the factors that causes the knocking? Means the fuel characteristics. So before using the certain fuel for the certain engine, we should properly study that. So if the fuel characteristics are not proper, means the C10 number, octane number, okay, calorific value, okay, are not proper according to the required engine, the knocking effect takes place. Next, the molecular structure. So the knocking also depends upon the molecular structure of the fuel that we are using. And next we have a third point, that is the self ignition temperature. So higher self ignition is preferable. If the self ignition temperature is lower, then it takes ignition lag and there will be a sudden combustion at the end of the stroke. So that causes the knocking. Next, the flame velocity. So here the flame velocity also, higher flame velocity is preferable rather than the low flame velocity. Okay. Next we have next point, conditions for charge, that is the air fuel ratio. Okay, there should be the exact air fuel ratio. And next, the density of the charge, that is also important. Next, the temperature of the charge in the sense the air fuel mixture. Okay, so these are some of the factors we have to consider in order to avoid detonation and knocking. And next point is the compression ratio. So the compression ratio should be appropriate for proper combustion and to avoid any knocking or detonation effect. Next, ignition. So ignition means we are going to provide the spark plugs. Okay, so spark plug plays a very important role here. We can't provide the spark plugs wherever we want. So it has to be provided in the proper location. There should be a exact timing for the ignition, so that there should not be any delay to avoid the knocking effect. And next comes the engine speed. So we should not give a sudden throttling. Slowly we have to rise it. So suddenly if you want to increase this, if you increase the speed, there also the knocking effect comes into the picture. And the next point is the combustion chamber. So where the combustion chamber is nothing but where the air fuel mixture combustion takes place inside the cylinder. Okay, so the combustion chamber has to be properly designed and it has to be properly machined to avoid the knocking or detonation effect. So shape of the combustion chamber, CC indicates combustion chamber, shape of the combustion chamber. Next we have the material and surface condition. So what are the materials we are using, okay, and what is the surface, how is the surface it is finished, that also affects the knocking or detonation effect. Next we have engine cylinder. Engine cylinder means the size of the engine cylinder, okay, and how the heat is dissipated from the engine cylinders. Okay, so how the cooling is we have provided for the engine cylinders, that is very important for us to avoid the knocking or detonation effect. So the other factors are like engine load. So the more you apply the load as per the required load, then the knocking or tendency takes place, detonation and knocking takes place. So to avoid all these things, these are the factors we have to consider for the smooth running of any engine. So students, if they ask you what are the factors, these are the important one. We have 7 factors. And if they ask you explain about the detonation and knocking effect, means you have to draw this circle diagram and you have to draw this P theta diagram and explain for the normal and abnormal combustion. Okay, and one more question they may ask you, which I have explained here, that is P theta diagram. It looks almost similar here, where we have a BDC, TDC and BDC, and I have mentioned angle on the x-axis. Like at the top TDC I have mentioned 0. When you go towards the left x-axis, the angle was going on increasing up to 80 degrees, and on the right side also I have shown it was increasing up to 80 degrees. So those are the angles we have to consider. So these are the some of the basic questions we may arise like this, man. So next comes on the first, they may ask you what is IC engine, classify the IC engine. With the P theta diagram, explain the P theta diagram for CI and SI engine, they may ask you. Next they will ask you what do you mean by detonation and what do you mean by knocking, and next they will ask you what are the factors affecting the knocking. So what are the material I am going to explain, I am sharing here. You can download this, and this is enough, man, for you people, for the exam, students, for the exam point of view. Okay, and next comes the performance parameters of the IC engines. So what are the performance parameters of the IC engines means? So we have first performance parameter is nothing but the indicated power. So what is an indicated power? Okay, so what is that indicated power? Indicated power is nothing but the power that is developed inside the cylinder is called as the indicated power. So you can see here, it is the power developed inside the engine cylinder. How the power is developed inside the engine cylinder means by burning the air fuel mixture. So when you send the air and fuel mixture into the cylinder in case of SI engine, and when you ignite the spark, the large amount of gases will be produced due to the combustion of the air fuel mixture inside the cylinder, and this, when you this pressurized gases makes the piston to reciprocate inside the cylinder. So this is nothing but the indicated power. And how to calculate this indicated power theoretical means IP equal to PMLANK divided by 60, so many kilowatts. So what is that PM? PM is nothing but the mean effective pressure. You can see here, PM is nothing but the mean effective pressure. And what is this capital L? Capital L indicates stroke of the cylinder, engine cylinder, and capital A is nothing but the area of the indicated cylinder. Okay, and N is the number of number of cycles. Okay, and K is nothing but the number of cylinders, and this small n indicates number of cycles. So how to find the cycles means, again it depends upon the 2-stroke engine and 4-stroke engine. So for 2-stroke engine, small n is equivalent to capital N. I have written here, you can note down. You can see, observe here, small n is equal to capital N for 2-stroke engines, whereas small n is equal to capital N by 2 for 4-stroke engines. So indicated power, how we are going to calculate means, the formula for indicated power is P suffix M LANK divided by 60, so many kilowatts. Why you are dividing this 60 means, usually N, what you have written, N is number of cycles, it will be revolutions per minute. Again small n is capital N, small n equal to capital N for 2-stroke engine, and small n equal to capital N by 2 for 4-stroke engine, where n is the speed of the engine, it is in terms of revolutions per minute. In order to convert revolutions per second, we are going to divide that by 60. Then you will get the indicated power in terms of kilowatts. So this is how we are going to calculate the indicated power. Indicated power is nothing but Planck. We can say in generally Planck. If you are unable to remember the formula, you remember at least the word Planck. Planck indicates, P suffix M indicates indicated mean effective pressure. L is the stroke length of the engine cylinder. A is the area of the piston. Small n is the number of cycles. K is the number of cylinders. If it is a single cylinder, you can take the value of K as 1. If it is multi-cylinder, you can take the value of K depending upon the number of cycles. Number of cylinders. How many cylinders are there? You have to put K value, so much value. So this is how we are going to calculate the indicated power, and it will be written in kilowatts. Okay. Yes student, I hope all of you understood what do you mean by indicated power, okay, and what is the formula for indicated power, and what is L, what is A, what is small n, how to calculate small n, and it depends upon the stroke of the engine. If it is two stroke, small n equal to capital N, and if it is a 4-stroke engine, small n is equal to capital N by 2. Okay, so this is how we are going to calculate the indicated power. Next comes the and one more thing I forgot to tell you. So how to calculate the mean effective pressure? So most of the cases in the problem they will give directly mean effective pressure. Sometimes they will give the spring value, area of the indicated diagram, and length of the indicated diagram. At that time we have to supposed to calculate the mean effective pressure using the formula Pm is equal to SA by L. Okay, Pm is equal to SA by L, where S is the spring value, it is a small s, okay, L is the length of the indicated diagram, and small a is nothing but the area of the indicated diagram. You look and observe here clearly students, the small a is different and capital A is different. Capital A is nothing but the area of the piston, whereas small a is the area of the indicator diagram. So if they give the length of the indicator diagram, area of the indicator diagram, and spring value, then you are supposed to calculate the mean effective pressure as SA by L. And what is that indicator diagram? I am going to explain now what is that indicator diagram means. So if you plot the graph of any running engine cylinder, okay, the engine will be plotted in zigzag way, that is a suction, compression, expansion, and exhaust stroke will be drawn. That is nothing but for entire completion of one cycle, the indicated diagram will be plotted on the graph. That is nothing but the indicator diagram. That area of the indicator indicates small a, and total length means perimeter of that is nothing but length of the indicator diagram. So to draw this indicator diagram, we are using one planimeter apparatus, okay, graphically. So that spring value is spring will be provided, that spring constant is the S value. Okay, so if they give mean effective pressure in the problem, it's okay. Sometimes they will give the spring constant, length of the indicator diagram, and area of the indicator diagram. At that time we are supposed to calculate that using the formula Pm is equal to SA by L. So after calculating this mean effective pressure, now we can substitute in the main formula PMLANK. Okay, that Pm you are supposed to substitute here, and you are supposed to calculate the indicated power. So next comes the brake power. So I told you what is indicated power. The power developed inside the cylinder is called the indicated power. Now comes the brake power. So whatever the power is developed inside the cylinder, we are not going to utilize all that power at the crankshaft. There will be some losses due to the reciprocating of the piston. Okay, so after considering that losses, whatever the power that is available at the brake drum or crankshaft at the brake drum is called as the brake power. So we can see here, it is the power measured at the crankshaft is called the brake power. And how we are going to measure this brake power means using the dynamometers. So we have different types of dynamometers students. I am going to explain later in the next class about this dynamometers. So the power that is available at the brake power at the crankshaft is called the brake power. Okay, and how we are going to measure this brake power means using the dynamometers, that is by applying the load on the brake drum. If you are going to apply the load on the brake drum, then it is called as the brake drum dynamometer. So we have different types of dynamometers. We have like if you apply the current dynamometer, like using the generator or to some other power sources like lighting, braking, something maybe power brake like that. So depending upon the time of that, again we have a hydraulic dynamometers, where you are going to apply the hydraulic load. With the help of the hydraulic pressure, we are going to apply the load on the brake drum. Okay, so if you have applied the load in terms of weights, that is called as the brake drum dynamometer. If you apply the load in terms of current, it is called as the eddy current dynamometer. If we apply the load in terms of hydraulic load, then it is called as the hydraulic dynamometers. So these are the three different types of dynamometers we have to measure the brake power. Okay. So what is the definition? What is the brake power meant? It is the power measured at the crankshaft using the dynamometers, that is by applying load on the brake drum. So when you come to the 5th semester, this practically you are going to do it, students. So now you just understand what do you mean by indicated power, what do you mean by brake power. So now brake power, the formula to calculate the brake power, it is given by brake power equal to 2 pi nt by 60, so many kilowatts. So 2 is constant, pi is constant, again n is the speed of this speed measured at the crankshaft, it is in revolutions per minute. To convert into revolutions per second, we have to divide by 60, and T is the torque. So using dynamometers, you are going to measure the torque. So what is torque? Torque is nothing but force into perpendicular distance. So how to calculate the torque? So torque is calculated by using the dynamometers, that I am going to explain next in the next class. It is nothing but force into distance. What is the force we are applying here? Means the load, that whatever the load we are applying on the brake drum, that is nothing but the force. It may be in kgs, so we have to convert into newtons by multiplying it by 9.81. So perpendicular distance, torque is nothing but force into perpendicular distance. How to find out the perpendicular distance means, so the low force whatever you are applying, that to the center point of the brake drum, that perpendicular distance is nothing but send up to the center force into perpendicular distance, that gives the torque. So if you apply the torque here, you are going to get the brake power. So you note here, brake power is always indicated, is always less than the indicated power, because there will be some losses while passing the power from the piston cylinder to the crankshaft. There will be losses. So always brake power will be less than the indicated power. Due to friction, there is a loss in power. This is called as the frictional power. Always the brake power will be less than the indicated power due to losses in the movement of the friction, that is called the frictional power. So total indicated power is nothing but brake power plus frictional power, or frictional power is nothing but indicated power minus brake power. Okay students, now you might have understood what do you mean by brake power, and what do you mean by indicated power, and what do you mean by frictional power. Now coming to the mechanical efficiency. Usually whenever we ask the students what do you mean by mechanical efficiency, means they will say output by input. What is the input we are giving here? We are supplying the air fuel mixture, burning, and we are going to develop the power, that is called the indicated power, that is the input. And what is the output power? Means the power, brake power, that is available at the crankshaft is called as the brake power. So output by input, mechanical efficiency is nothing but output by input. So mechanical efficiency is nothing but brake power by indicated power, that is nothing but the mechanical efficiency. So into 100 to convert into percentage. So usually almost engines, the maximum percentage mechanical efficiency will be not more than 40%. Okay. So students, I have explained you some performance parameters, like what do you mean by indicated power, how to calculate indicated power, and what do you mean by brake power, how to calculate the brake power, and what is mechanical efficiency, and how to calculate the mechanical efficiency. So in the next class, I will explain you how to measure the torque, and we have some more performance parameters. Okay. So you do one thing. So whatever I am going to share it today, students, you please go through those, okay, and you write it properly in separate notebook. Okay students. Okay, take care students, goodbye, and don't move anywhere. Please stay at home, okay, and try to concentrate on the subjects, especially applied thermodynamics. It is not so easy. You have to be daily up to date. Okay. Bye students.